Part 2 starts from here. Now the next question. A moving train is brought to rest within 20 seconds by applying brakes. You can see a moving train here. It is brought to rest within 20 seconds by applying brakes. So it is brought to rest by applying brakes. So which of the velocity is zero, whether the final or the initial? Let's consider those important points. So if a body starts from rest, then the initial velocity is zero, but if a body comes to rest or stops, then the final velocity is zero. And here it is given that the moving train is brought to rest by applying brakes. That means initially it was moving with some velocity, say u, and when the brakes were applied, it was brought to rest. So that means the final velocity is zero, and the time taken for doing so is 20 seconds. We need to find the initial velocity if the retardation due to brakes is 2 meters per second square. Now, first of all, let us analyze what is given and what needs to be found. The final velocity is zero. Acceleration is minus 2 meters per second square. Why? Because it is given retardation due to brakes. The velocity is decreasing. So as the velocity is decreasing, so the acceleration will be negative, what we call as retardation. That is why we have used the sign here, that is minus 2 meters per second square. So when we are taking into consideration the negative acceleration, that means when a body is coming to rest, or what we can say when the final velocity is less than the initial velocity, in that case the acceleration is decreasing and it is considered as retardation, and the value will have a negative sign. And the time is given as 20 seconds, and we need to find the initial velocity. Here we need not to do any kind of conversion. We'll be just using the appropriate SUVAT equation to find the value of initial velocity. Before proceeding further, I would like to tell here that there's a common mistake that everybody does. Here I have written moves with uniform acceleration, then A is zero. It is not uniform acceleration, it is uniform velocity that the acceleration is zero. Acceleration is zero when initial and final velocity is same. That is what we call uniform velocity and not uniform acceleration. Here the initial as well as the final velocity will be different, so we will not consider this parameter. So which SUVAT equation we need to choose? Again, in this question the value of distance is not given, so we will not be using these two SUVAT equations because these two equations requires the value of the distance. So we will be using this SUVAT equation to find initial velocity, that is v equals to u plus at. Now v is zero, u we need to find, then the acceleration is minus 2 meters per second square, and the time is 20 seconds. So 0 is equals to u minus 40 meter per second. So if I take this here, this comes out to be 40 meter per second. So this was the initial velocity with which the train was moving. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.